accelerated precalc, lesson 1.2 of functions. So let's talk about what the definition of a function is. So in math, for a function f to exist, every x value in the domain is paired with exactly one y value in the range. Okay. Now remember, the x values or the domain are considered the inputs of the function, and the y values or the range are considered the outputs of the function. Okay. So let's take a look at some scenarios. Let's say we have a table here: -2, 1, 3, 0, 1, 4. So over here, for every x value here, right, it matches up with exactly one y. Okay. So the main thing, like if you're given a table, what you want to remember is that the x values cannot repeat. Alright, if the x values do not repeat, then this is considered a function. So this right here would be considered a function. Okay. Now let's see, we have another scenario. Some x's and y's. 2, 3, 3, 4. And then -1, 0, 2, 5. So over here we have x, which is 3. It matches up with 0. But the same x, right, 3, also matches up with 2. So we have the same x that goes to two different y values, right? By our definition, it says every x value in the domain is paired with exactly one y value, right? So if you have the same x matching up with two different y's, then this is not a function, right? So that's why basically the x values cannot repeat, because then it wouldn't match up with our definition here. Okay, so over here this would not be a function, not a function. Now keep in mind, if you have something like this, let's say you have -3, 2, 4, but the same y value, right? Let's say 1, 1, and 1. So this x, right, -3 matches up with 1. A different x, 2, also matches up with 1, but that's okay, right? Because it's a different x value, right? And over here, a different x, 4, matches up with 1, right? So the y's can repeat, right? So what you want to remember is the y's can repeat in order for it to be a function. So as long as the x's do not repeat, it's a function. So this would be a function. Okay? So let's take a look at an example here. So number 1. So our inputs, right, our x values, I see that the 2 repeats, so we know that this is not a function. Okay? And then over here, well, we've got vertical line tests. We've got a graph. If we draw vertical lines, remember it can only touch, right, the graph one time. So I notice if I draw vertical lines through all these points, it only touches one time through each line, right? So this would be considered a function, right? So this is a function. Okay, so pretty easy. All right, so one thing I want to talk about functions, right, are dependent and independent variables, right? So x is considered the independent variable, and y is considered the dependent variable. For example, let's say we have the equation for a parabola, right? Y equals x squared. The y value depends on what x is, right? So like for example, if x is equal to 2, we know over here y is going to equal 4. If x is equal to 5, we know y is going to equal 25. So x is the independent variable, and the y in this case is the dependent variable, right? Y depends on what x is. That's basically what this is saying, okay? Another thing I want to mention so that you guys understand how they kind of talk about functions sometimes. Let's say the area of a circle, right? The area of a circle, the formula is a is equal to pi r squared. I'm sure all of you know that. Well, what you need to understand is right here, basically the area of the circle is a function of the radius. Okay, so here's our formula here, right? So the area of the circle is a function of the radius, okay? Meaning the area depends on what the radius is. If the radius is, the bigger the radius gets, the bigger the area will be, right? So when you guys hear the phrase a function of, that means that the dependent variable, in this case the area, is is dependent upon the independent variable, in this case the radius. Okay, so if you see a formula like this, basically this says, hey, the area of the circle, this is written where the area of the circle is a function of the radius, right? The area depends on the radius. That's what it means to be a function of. Okay. All right, so let's take a look at example 2 here. So how do we know if these are functions, right? Which of the equations represents y as a function of x? All right, so y as a function of x, meaning y depends on x. So basically our definition of a function. So which one of these are functions? Well, in order to determine that algebraically, right? Algebraically, what you want to do is you want to solve for y. So you need to get y by itself. So here it's real simple. You minus the x squared. Y is equal to x squared, right? Negative x squared plus 1. And then just think, if I plug in values for x here, can I get two different y's, right? So for example, if x is equal to 2, right here, I would get y is equal to negative 2 squared, which is 4 plus 1. So y would be negative 3, right? So if x is 2, y is going to be negative 3, and it's never going to be anything else. When that's the case, right, then this is a function, okay? So when x is 2, your y value will be negative 3. It cannot be anything else. So in that case, this is considered a function, or y as a function of x. Okay. Now let's take a look at example B here. If we get y by itself, we get y squared is equal to x plus 1. And then we square root both sides. So y is equal to, so we need the plus or minus, right? Because we square root of both sides. Now in this scenario, well, if let's say x is equal to 1, right? If you plug in 1 here, y is going to equal radical 2. If you plug in 1 again, it could also equal possibly negative radical 2, because we have a plus and a minus here, right? So the same x gives you two different y values, right? So think of it as a table, right? The same x is giving you different y values, right? So remember, this is in this case, it's kind of like the x's are repeating, right? So when x is 1, we get radical 2. But when x is 1 again, we get a different y, negative radical 2. All right, so the x's are like repeating. All right, so when you have the same x giving you different y values, you could think of it as, hey, the x's are repeating, which lets you know that this is not a function. Okay. All right, number 3 here. So evaluating, this is real simple. So if we need to, here's our function, right? We need to find g of 2. Well, this means that in the g function, wherever there's an x, you're going to replace it with 2. All right, that's what this notation means, okay? So you guys always need to understand what that notation means. So over here, be careful how you plug it in. So this is negative, parentheses, 2 squared plus 4, parentheses, 2, right, plus 1. So this will give you negative 4 plus 8 plus 1. So we'll get positive 4 plus 1. So g of 2 is going to equal 5. Right, so do the same thing for g of t. Wherever there's an x, replace it with t. So I'll give you negative t squared plus 4t plus 1. And there's nothing else to do there. So we need to find g of x plus 2. Wherever there's an x, replace it with x plus 2 squared plus 4 parentheses x plus 2 plus 1. So over here, we have to do the exponent first, so use our binomial foiling shortcut, x squared plus 4x plus 4. Then we distribute the negative, negative x squared minus 4x minus 4 plus 4x plus 8 plus 1. So then let's simplify, so we're going to end up with negative x squared So negative 4x or positive 4x, they cancel, right? So then we've got negative 4 and 8, that's 4, plus 1, that's 5. So g of x plus 2 is equal to negative x squared plus 5. Alright, so real simple, nothing complicated. Alright, so let's take a look at this function here. So all of you should be familiar with the function y is equal to absolute value of x. Okay, so by definition, when you have the absolute value of x, you can rewrite this as a piecewise function. So basically, you could rewrite it as x, and then with the domain x greater than or equal to 0, or negative x with the domain x is less than 0 right here. So here's basically this right here, this part of the v, and the negative x right here gives you this part of the v right here. All right. So now what you really need to remember is, look, every time I have y is equal to absolute value of x, the graph of that is going to be a v. Okay, it's going to be a v. So if you guys can sketch this really quick, you guys can always find out, what the domain, the range, or the intercepts are, or when is it decreasing, when is it increasing, if you understand how to sketch this. Okay, so the main thing is, remember that y equals absolute value of x is this basically this v-shaped graph right here. Okay, and from this you should be able to determine all these all these over here, just in case if you were to be asked for it. All right, example 4, a piecewise-defined function. So we have a piecewise here, right? So they want us to find out, hey, what's the function when x is equal to -1? So if you're trying to find f of -1, you have to think, well, which domain does it belong in? Well, for this part of the piecewise, that's when the domain is x is less than 0, right? And then for this one, it's when x is greater than or equal to 0. Well, -1 belongs to this domain right here, it belongs to this domain. So we're going to plug it into this part of the piecewise. So we have -1 squared plus 1. Well, that's just going to give us 2, right? And then how about when f of 0? Well, where does that belong to? Well, this is when x is greater than or equal to 0. So it belongs to this domain. So we've got to plug it into this part of the piecewise. 0 minus 1, that gives us -1. Right? Super easy stuff. Alright, so next thing, so we have a radical, right? So we have y is equal to square root x. So we always have to remember that this graph here basically looks like half of a sideways parabola, or half a sideways parabola. Okay? So if you remember that this is what the graph looks like, you can always sketch this right here and determine all these, questions right here. If I ask you for the domain, range, intercepts, when's it increasing, you can give me all these answers after you've made this sketch. So I really don't want you guys memorizing this right here. All you really need to remember is, hey, y equals square root x, the graph looks like this. And once you sketch the graph, from looking at the graph, you should be able to give me all these answers right here if I ask for any of these. Okay? Alright, so when we're talking about finding the domain of a function, right? When you're trying to find the domain of a function, there's two things that you never want to happen. One, you don't want to ever divide by 0, right? And two, you cannot have a negative inside any sort of radical that's even index, right? Like a square root or a fourth root. Anything that's an even index, you cannot have a negative inside the radical, because that means that you're working with the imaginaries. Okay, so these are the two things that you never want to happen when you are trying to find the domain of a function. Okay, so x can be anything except for the numbers that that cause these two scenarios to occur. Okay, so let's take a look at an example. All right, so example 5 here. So we need to find the domain of this function. Okay, so we'll start with example A here. So here's our function, and they give us a bunch of points. Okay, well, our domain, remember, the domain are the x values. Okay, so what are all the x values of this function? Well, it's going to be -3, -1, 0, 2, and 4. Right? Now keep in mind, you have to list out these values like this, right? if you say, like if you use interval notation and tell me, hey, it's -3 to 4, this would be completely wrong, because what you're saying here is from -3 to +4, you're counting all of these x values. That's what this means, okay? But remember, the x values in this function are only -3, and then it jumps to -1, and then it jumps to 0, and then it jumps to 2, right? So it's not counting every single value in between these, right? So understand the difference between this notation here and interval notation, which means you're counting everything between these, these values, okay? Let's take a look at example. All right, so example B here. So taking a look at this polynomial here, so we know this is a parabola, right? And remember, when you're trying to find domain, there's two things you do not want to happen. You don't want to divide by 0, and you don't want a negative in your radical. Well, looking at this function here, there's no division going on, so you're never going to divide by 0. And we have no radicals, right? So that means that x can be anything, right? X can be any value. So in interval notation, the way we represent that, -infinity to infinity, okay? And if you think about it, this is really just this is just like a parabola that's just going to open down somewhere, right? It looks something like this, right? So if you think about it, it's going to keep on getting wider as it goes down. So isn't the domain, isn't this going to just cover the whole x-axis forever from, -infinity to infinity, okay? So always understand the visual of what's really happening, right? Let's take a look at the next example here. So we've got C. Well, we don't want to divide by 0. So x can be anything, but we don't want it to be -5. So x cannot be equal to -5, because then that's going to make 0 down here, right? So in interval notation, well, that's from -infinity to -5. And then union, all right, -5, all right, to infinity. Okay, now remember at -5 here, we have the parentheses because we don't want to include -5, right? So this basically says, hey, the whole number line except for -5, okay? Example D here, this is the formula for the volume of a sphere, right? As a function of the radius, right? I want you guys to understand that, right? The volume of the sphere as a function of the radius, meaning it depends on what the radius is. So what would the domain be? All right. Now remember the idea of domain. I don't want you guys to just be able to find answers but not understand what you're doing. Domain are the values that you can plug into the function that will give you out a valid y value, right? The values aren't the x or r values in this case that you can plug into the function that will give you out a valid, y output, or in this case v, right? So can we plug anything in here for the radius? No, right? The radius has to be positive. You can't count negatives here, right? I've never seen negative radius. And the radius cannot be 0. If the radius is 0, you have no volume, okay? So basically, r has to be greater than 0, right? So the way we express that in interval notation, go from 0 going to infinity, right? We don't count 0, then we go to, all right, infinity. So basically all the positive values are okay, right? And then over here, we don't want the inside of this radical to be negative, right? So we just take whatever it is inside here. We want it to be greater than or equal to 0, okay? So remember, it could equal, can we have the square root of 0? Yes, this is fine. We just don't want it to be negative in here. So that's why we have the equal to part here. So we solve, so we get -3x is greater than or equal to -4. We divide by -3. Remember, when you divide both sides by a negative, you have to flip the inequality. So 4 is less than or equal to 4/3. And the way we express that, well, in interval notation, right? Well, let me show you the number line first. So let's say we have 4/3, right? So we count 4/3, so we close bubble. And less than, so all these values, right? So basically interval notation, remember we work from left to right. We're coming from -infinity, all right, to 4/3. So in interval notation, we have -infinity, and then we stop at 4/3. And yes, we can include it, so we use a bracket, okay? All right. The next example here, so let's say we need to find the domain and the range graphically, right? So let's say you're allowed to use a graphing calculator. you graph this right here, and you get this graph. Well, the domain means how much of the x-axis does this graph represent, right? Does it cover? All right, it covers this part of the x-axis, right? Well, so that's basically from 1, 2, 3, -3 to +3, right? So your domain would be -3 to +3, right? Now, can we include these points? Yeah, because if you plug in -3 here, right? You plug in -3 squared, that'll give you 9. 9 minus 9 is 0. Remember, the square root of 0 is okay, right? We just don't want it to be negative inside. The square root of 0, that's fine. What we don't want is a negative inside, right? We don't want that. And then, now I want you to understand what domain is. Domain means that, look, if you plug in any of these x values, you're going to get out a y value, right? If you plug in x is -1, you go up to the graph here, this is what the y is going to be, right? So you notice here, like if you plug in 4, all right, if you plug in 4 here, what happens? You're going to end up with a negative radical, right? That's not in our domain. That's why if you go to the graph here, you go to 4 on the x, you try and go up and down, you're never going to hit the graph, right? So that's what it means when you're finding the domain of a function. These are all the x values, right, that you can plug into this function that will give you out a valid y value, okay, y value. All right, what's the range now? Well, the range is how much of the x-axis, how much of the y-axis is covered. Well, the y-axis is covered this much, right? So the lowest it goes to is 0 on the y-axis right here, 0. And the highest it goes to is 1, 2, 3. So our range is 0 to +3. And that would be our range, okay? All right, here's kind of like a real life scenario. So let's say a baseball is hit at a point 3 feet above the ground, right, at a velocity of 100 feet per second and at an angle of 45 degrees. So the path of the baseball is given by the function, right? So here's the function here, where x and f of x are measured in feet, right? So this represents the path of the baseball. Basically, x represents how far the distance traveled, right? The distance traveled, all right? And then f of x is basically, that represents the height of the ball at any moment, right? Dependent on the distance traveled, okay? So the question is, will the baseball clear a 10-foot fence located 300 feet from home plate? So your x is 300, okay? We need to find out what f of x will be when x is 300. So what you're doing is you're just plugging in 300 into the function, right? 300. 300. Right? And over here we have the negative 0.0032. So you work all this out. So I'm going to just save some time. It turns out f of x is going to equal 15, right? When x is 300. So let me just write it correctly. So when the ball has traveled 300 feet, it will be at a height of 15 feet, okay? So will it clear a 10-foot fence? Yes, it will, right? It will clear a 10-foot fence, right? Now I want you guys to understand the visual of this, so let me show you that. All right, so I graph our function, right? So here's our function. If you graph it on a graphing calculator, you would get this, right? It's just an upside down parabola, right? And you guys already know that. So basically, here's the scenario. So x, right? Our x is the distance traveled. So if it's gone 300 feet, so as you know, this is the distance traveled, right? So it keeps on going. So at this point right here, it's gone 300 feet. It's gone 300 feet. And how high is it? All right, well, that's going to be 15. That's basically what we figured out. The y value was 15. All right, so that's what's happening. So, you know, someone hits the ball, it's traveling, it comes back down. So after traveling 300 feet, it's at a height of 15 feet. Okay, so I want you guys to understand the scenario of what's happening. All right, so the last thing we need to talk about is the difference quotient. Okay, this is a very important kind of formula that you need to remember. Right, in second semester we'll talk about where it comes from and what it represents and what it means. So first semester, we kind of just learned how to do the algebra behind it, all right, and how to kind of evaluate it. All right, so anytime I tell you, hey, find the difference quotient, I am telling you to find this. Okay, so you have to memorize this. Right. So let's do an example. All right, so the difference quotient. So here's the difference quotient, right? And here's the function that we were given. So first we need to find this part right here. What's f of x plus h? So to find this, what this means is, hey, wherever there's an x in the function, we are going to replace it with x plus h. That's what this means, okay? So we have x plus h squared, right? So I'm replacing it right there. Minus 4 times x plus h plus 7, okay? And then now we are going to subtract minus f of x. F of x is just this, right? F of x is equal to the function right here. Now here's something you have to remember. I want you guys to put a parentheses around the f of x so that you're always going to remember to distribute this negative, okay? So we have minus parentheses and then whatever f of x is, x squared minus 4x plus 7, right? And then this is all over h, right? So we're going to work this out. So I'll work this out. So we use our binomial foiling shortcut. So we get x squared plus 2xh plus h squared minus 4x minus 4h plus 7. And then we distribute this negative here, here, and here. We get negative x squared plus 4x minus 7 all over h, right? Well, I'm going to start canceling stuff out. So it looks like this and this cancels, the 4x, and the negative 4x cancels, the 7 and the negative 7 cancels. So it looks like the only thing we're left over with is 2xh plus h squared minus 4h all over h. And we have a h as a GCF up at the top, so we take that out. So we take out the h, so we end up with 2x plus h minus 4 over h. And then what happens? The h's divide out, so we're left over with 2x plus h minus 4. And that's your answer, okay? Keep in mind, if you do this correctly, every time you evaluate the difference quotient, if you do everything correctly, you should never have an h in the denominator anymore, right? The whole point of the difference quotient is so that we end up with something and we take out this h as a GCF and it'll cancel with the denominator, right? So if you still have an h in your denominator as your answer, then there's a good chance you're probably doing something wrong, okay? So this is the difference quotient.